Okay. If you have books, circular motion and a simple harmonic motion. In grade 9, we studied the types of motion. There were three types of motion. Translational means linear, then rotational, and then vibrational. Rotational is further having three types. One of the types was circular motion. Is it? So circular motion, the motion of an object in a circular path. Simply, if the object is moving in a circular path, if the object is moving in a path in the form of a circle, then this motion is called as circular motion. And what was simple harmonic motion? A motion in which acceleration is directed towards the mean position and acceleration is always directly proportional to the displacement. Okay. Let me tell you very frankly, this topic is the difficult of the topics we have studied so far. Okay. Why it is a difficult topic? If you look at the name, circular motion and simple harmonic motion, it means we have to prove diagrammatically, graphically. We have to consider at the same time the circular motion of an object and the simple harmonic motion of an object at the same time. Now, if you look at this diagram, this is the spring attached to a mass. So it means this motion we have studied in simple harmonic motion. And this simple circle is showing us that the object is moving in a circular path. So we have to relate these two motions graphically. Introduction is written on the books. If you are having books, let us consider the same situation. They are saying, let there be a particle of mass m burning in a horizontal circle of radius r with angular velocity omega. A distant light causes a shadow of mass m on wall. Means if something is happening, suppose if a wheel of a bicycle is rotating in the center of the room and I spark a light on it, definitely its shadow will be created on the opposite hand side. So they are creating the same scenario. A distant light causes a shadow of mass m on the wall. The shadow executes simple harmonic motion. Similarly, when a particle moves in a vertical circle, its projection vibrates simple harmonic on the diameter of the circle, having time, period, frequency, and acceleration. So they say, if the object is moving a circle, the shadow of this object, the shadow of the object is moving in a vertical situation like this. So we have to consider this and we have to take this vibration and then correlate them to find our time period, frequency, acceleration, velocity, displacement. Got it? So doing one by one. I will share this definitely. You can use the same diagram because I made it so simple. Listen. This is a circle, is it? This is the center of the circle. I name it as O. Origin, it is easy for us to name this origin as O. Okay? We know that the distance from the center of the circle to any point on the circle is called radius of the circle. And if you look, the radius of the circle when the object is at the center of the circle and when object is touching the point P on the circle or the point D on the circle, it is equal to the amplitude. What was amplitude? The maximum displacement from the mean position. So when the object reaches from P to D, this pointer reaches from 0 to maximum position. So therefore, instead of writing R, simple radius, I simply wrote it as x naught. We know that x naught is the amplitude. Okay? If you want to write R, you can write R. But why I wrote x naught? X naught is telling us the amplitude. If you look at the topics, previous topics, the definition which we did, look here on page number 226, amplitude and displacement. So displacement is simply represented with x and amplitude is represented by x naught. Is it? So I just wrote it as x naught because it is the distance from the center of the circle to the point on the surface of the circle. So let it be x naught. Clear? Anywhere other than amplitude, other than the maximum distance, anywhere if the pointer is in between from the center to anywhere in the circle, it is simply a displacement. What is displacement? For example, I am standing at this position. This is my origin. I have to go, means my limit is to go toward the ball. When I am starting move and reaches here, it means I have covered maximum distance. So this maximum distance is called amplitude, and this is called x naught. Okay, but what is displacement? Again, that is my maximum limit. If I am moving, I am stopping here. This is my displacement. It is not amplitude. Okay. If I am stopping here, again this is my displacement. If I am stopping here, again this is my displacement. Till here, all the infinite points are my displacement until I touch this. So only this point is amplitude. Other than all distances are displacement. Got it? So from the center to the circle, it is x naught. From anywhere in the middle of the circle, it is simply x. Got it? So x means distance and x naught means amplitude. Clear? If you look at the diagram, now it is becoming a right angle triangle. O, let this be O1 when your object is about to start. This is point P where your object reaches after some time t. So this is a right angle triangle. Got it? Making an angle theta to the center of the circle. Clear? Now we will be finding one by one the terms associated with this motion. It's in the no, it's in the image. I will share. Okay. I have made one means separate diagram so that you can understand. Okay, it means the first diagram is just to introduce. What is instantaneous displacement from the diagram which we just discussed? So again, let it make more simple. This is only a circle, is it? Center, from center to any point, it was my amplitude, maximum distance, okay? And from center to any point within the circle, it is my displacement simply x. Okay? So this is making my right angle triangle OP. Is it? Clear? What we are going to find out? Displacement. Is it? So in triangle O and P, sin theta. What is the formula of sin theta? Simply the formula.
Cos divided by tan.
No, इस तरह नहीं. ये cos divided by tan कौन सा sin आ गया? Sin theta means perpendicular over I told you this was the angle. Okay, and here I made it as O1. So if I am taking this triangle, O1P, if I am taking this triangle, it means theta is here. Then what is the perpendicular? Perpendicular is this side. Got it? And in grade 9 you also studied the theorems, triangular theorems, in which we studied alternate angle of triangles are base concurrent. What are the theorem? So J angle and this angle, these both will be equal to each other. Okay. That's why, since I didn't give any name to this side, I am taking this triangle O and P. Therefore, angle P and this angle will be considered to equal. So, side opposite to the angle is always perpendicular. This is base and this is hypotenuse. Okay? So, in triangle O and P, sin theta is equal to perpendicular over hypotenuse. What is perpendicular? What is the side opposite to this theta? ON. Is it? So ON. What is hypotenuse? OP. Inclined. OP. What was ON? ON was X. What was OP? OP is X naught. Just put the value, you will get sin theta equals to X over X naught. Is it? Is it clear so far? What was the heading? Displacement. What was displacement? Is it X or X naught? X. So if we want to find out X, where this X naught will go? It will be cross multiplied, is it? So X will become X naught sin theta. Is it? Clear? So this is the linear displacement. This is linear displacement. Is it? And I told you what is the relationship between theta and angular velocity. It is theta equals to omega t. Okay? When you replace your theta with omega t, it means your displacement is no more linear, it becomes angular. Got it? Angular means in a circle. Because we are taking two motions. One is simple harmonic, one is circular motion. So this is for circular, this is for bidirectional. Got it? So we just replace theta with omega t and your equation could become as x equals to x naught sin omega t. Clear? And what was omega? Wasn't it 2 pi by t? We did it last time, means I did it on Thursday. I don't know whether you were online or not, but we did it. Omega is equals to 2 pi by t. Omega equals to 2 pi by t. Let me explain one by one. Just remember your omega is equals to 2 pi by t. Is it? Equation was x is equals to x naught sin omega t. Is it? And I just wrote x equals to x naught sin 2 pi by t into small t. Is it? Now I have a question to all of you. This is a complete circle. Is it? This is a complete clock from 0 to 12 o'clock. Is it? Let me divide it into 4 equal halves. This is 0. Is it? From here to here of 1 hour. if it is making a 1 hour from here to here, how many minutes? 15 minutes, is it? So can I write it? Means can I write this time that I divided this portion, that is basically t equals to t by 4, is it? Overall time was t, I divided with 4 and I got this, is it? Can I write it? When it reaches here, this here, don't you think can I write it as 2t by 4 or simply t by 2? Means I have covered my two quarters. Is it? When it reaches here, can I write?
It's about this radian,
A radian is basically represented by pi. I'm not writing. I'm just trying to elaborate in terms of time. Means how I can make 1 hour or one complete circle into 4 equal parts. Okay? So when it reaches here, it means how many quarters it covers? 3 quarters out of 4 quarters. So can I write it as 3 by 4 quarters? And when it reaches here, how many quarters it covers? All 4 quarters it covers. So t equals to 4t by 4 or simply t, because 4 and 4 will get cancelled. Is it? So putting 1 by 1. Because we know that it is an instantaneous displacement, and what was instantaneous displacement? At any instant of time. So let me ask you, what is the displacement at t equals to t by 4? So in first case, at t is equals to t by 4. Let us check what the equation will make. X is equals to x naught sine 2 pi by t multiply by, in place of small t I will write t by 4. What are the quantities that could be cancelled? This t and this t could be cancelled. 2 ones are 2 twos are. So what is left? X naught sine pi by 2. Is it? Now what is pi? In general, what was the value of pi?
3.1.
No, इस तरह नहीं. In angle, in degrees. 1 pi equals to how many degrees? That was 2 pi. 1 pi is equals to 180 degrees. Is it? And pi by 2 is? भाई pi जो है 180 डिग्री के बराबर है. pi equals to 180 degrees. So pi by 2 किसके बराबर होगा? What is the value of pi by 2? 90 degrees. M1 is not a rocket science. So it is x naught sine 90. And what is the value of sine 90? We all know that is 1. Is it? So 1. So x naught multiplied by 1 is x naught. Got it? Clear? If I ask you what is the instantaneous displacement at t is equals to t by 2, let us check. At t is equals to t by 2, x is equals to x naught sine 2 pi by t multiplied by t by 2. What are the things we can cancel? 2 and 3. 2 and 2, t and t. What is that? X naught sine pi. I just told you what is pi? 180 degrees. X naught sine 180 degrees. 180 degrees is equals to, अगर if you check it on calculator, sine 180, what is it equal to? 0 degrees. So 0 multiplied by anything? 0. Got it? If I ask you what is the instantaneous displacement at t is equal to 3t by 4, then x is equal to x naught sine 2 pi by 2 multiplied by 3t by 4. What are the things we can cancel? 2 and 4, 2 pi by t. So t and t will get cancelled, and 2 2s are. So what is left? X naught sine 3 pi by 2, and 3 pi by 2 is 270 degrees. X naught sine 270 degrees. You can check on calculator that sine 270 degrees is equal to -1. So when -1 multiplied by x naught, we will get minus x naught. Is it? And what is the last case? At t is equal to t, not 40. At t is equal to t. X is equal to x naught sine 2 pi by t multiplied by t. What are the things? T and t will get cancelled, and only we will be left with 2 pi. 2 pi is equal to how many degrees? 360 degrees. 360 again 0, 0 multiplied by anything? 0. Now let me draw the diagram. T equals to 0. What was my final result when at t equals to t by 4? Was it maximum x equals to x naught? Maximum displacement, is it? This was the first case I got x is equal to x naught. So it means here I got full displacement. My body starts from here. So it means the simple harmonic motion will reaches to its maximum value. Is it? What is the second case result? 0 means when the body reaches at this point, the displacement will become 0, and definitely it has to come from maximum to the 0 position again. Is it? When it comes to the third quarter, what was the displacement? Isn't it x equals to minus x naught? Means in the other direction. Minus means the other direction. So it means now it will go up or down? Down. It started from middle, it goes up, down, and this is the mean line. It will go down now. The spring is vibrating like this. Okay? So this was the mean position. So it will again go down. So here it will get minus x naught. Clear? And finally, when it covers all the fourth quarter, what was the displacement result? Means it has to again come back to the mean position. So it will come back here and displacement will become 0. So this is how uniform circular motion and simple harmonic motion can be correlated when the object is doing simple harmonic motion or circular motion. Clear? Issue है मन? अल्लाह की मर्जी. रेस करो. सर सबर कर जाएगा आपको तो